The dream of supersonic travel is back. Boom, Supersonic promised to bring back the glory days of the Concorde, but faster, greener, and affordable. Yet years later, there's still no passenger jet in the sky. What's really going on behind the scenes? From delayed test flights to engine setbacks and skeptical investors, Boom's project, Overture, has become a mystery of modern aviation. Today, we'll uncover what's really happening with Boom's supersonic jet, and whether this is the future of flight or just another impossible dream. In 2014, a former Amazon executive named Blake Scholl had a wild idea: to bring back the thrill of supersonic air travel, something the world hadn't seen since the Concorde was grounded in 2003. But Scholl didn't just want to recreate the past, he wanted to reinvent it. His company, Boom Supersonic, set out to build the Overture, a sleek passenger jet capable of flying at Mach 1.7, nearly twice the speed of sound, while running on 100% sustainable aviation fuel. The goal was bold: make supersonic flight not just faster, but cleaner, quieter, and affordable for airlines. Boom's pitch was simple yet revolutionary: a New York to London flight in just under 4 hours, cutting the trip in half. And it wasn't just talk. Major airlines like United and American Airlines placed pre-orders for dozens of aircraft, showing that this wasn't just a billionaire's fantasy. It was a serious attempt to redefine long-distance travel. The design of the Overture is mesmerizing: a long, needle-like fuselage built for aerodynamic efficiency, 4 engines mounted under the wings, and a cruising altitude of over 60,000 feet. From there, passengers would literally see the curvature of the Earth. Boom claimed it would be the most sustainable supersonic jet ever built, designed to meet the world's toughest noise and emission standards. But behind the futuristic renderings and sleek marketing videos, the question lingers: can they really pull it off? The Concorde was a marvel, but it was also an economic failure: expensive to fly, noisy, and restricted to limited routes. Boom promised to fix all of that with modern technology and better economics. Yet, making a supersonic jet profitable in today's carbon-conscious world is an entirely different challenge. Still, there's something undeniably exciting about Boom's ambition. In a world where innovation often feels incremental, a slightly better phone, a slightly faster car, Boom dares to dream big again. It's a company betting that speed still matters, and that the golden age of aviation can return, but smarter this time. And before we dive into how Boom plans to overcome the impossible, make sure to subscribe to the channel and turn on notifications, because in this video, we're uncovering what's really happening behind the scenes of the most ambitious jet project in the world.
Designing a supersonic jet in the 21st century isn't just about speed. It's about solving problems that even the Concorde couldn't overcome. And at the center of Boom's struggle is one critical piece: the engine. Originally, Boom partnered with Rolls-Royce, the legendary British engine maker behind the Concorde's Olympus engines. But in 2022, Rolls-Royce quietly pulled out of the project, stating that it had no plans to pursue a commercial supersonic engine. That left Boom stranded. Without an engine, even the most elegant jet is just a static sculpture. In response, Boom announced an incredibly ambitious plan. It would build its own engine from scratch, a move almost unheard of for a startup. They called it the Symphony engine, a medium bypass turbofan designed specifically for Mach 1.7 flight. The company claims it will be 25% more efficient than Concorde's engines and will run entirely on sustainable aviation fuel, SAF. But developing a jet engine is one of the most expensive and technically complex feats in modern engineering. Even giants like GE or Pratt & Whitney spend billions of dollars and decades perfecting new designs. For Boom, with fewer than 200 employees and limited capital, it's a Herculean task. Beyond the engines, the aerodynamics and materials present additional challenges. At supersonic speeds, the aircraft's surface endures extreme temperatures and stress. Boom's engineers are using advanced carbon composites instead of aluminum to reduce weight and improve heat resistance. The jet's delta-shaped wings are optimized for stability and fuel efficiency at high speed. but designing them to also perform efficiently during takeoff and landing is another balancing act. Then comes certification. Supersonic flight regulations today are far stricter than they were in Concorde's time. Noise restrictions, especially the sonic boom, are a major obstacle for overland flights. Boom claims its aircraft will be quieter, but it's still unclear whether regulators will allow it to fly supersonically over populated areas. So far, Boom's smaller prototype, the XB-1, has undergone ground tests and taxi runs, yet it still hasn't completed a full supersonic flight as of now. Boom's vision is breathtaking, but so is the list of technical hurdles. The question isn't just whether they can make a supersonic jet, it's whether they can make one that's safe, certified, and economically viable. And that's where the next challenge begins: money. For all its ambition, Boom Supersonic faces a problem that has killed many great ideas before: money. Building a brand new aircraft program from scratch is one of the most expensive ventures imaginable. The last time someone successfully did it was decades ago. And even then, it required billions in government support. Boom doesn't have that luxury. It's a private startup, depending on investors, airline deposits, and optimism. The company has raised more than $700 million so far, an impressive figure for a startup, but still just a drop in the ocean compared to what's needed. Industry experts estimate that developing and certifying a new supersonic jet could cost $6 to $8 billion before the first passenger ever boards. That means Boom needs deep-pocketed partners or continuous rounds of funding to keep its dream alive. Then there are the delays. Boom's smaller test aircraft, the XB-1 Baby Boom, was originally scheduled to fly years ago. It's completed taxi tests, but no confirmed supersonic flight has been announced yet. The company keeps pushing back key milestones: first flight of Overture, engine tests, factory openings. And while that's normal in aerospace, it erodes confidence. For every delay, investors grow more cautious and critics more vocal. Some analysts question whether there's even a business case for supersonic travel. The Concorde failed not because it couldn't fly fast, but because it couldn't make money. Tickets were astronomically expensive, maintenance was brutal, and routes were limited to oceans where the sonic boom wasn't an issue. Boom insists that new technology and sustainable aviation fuel, SAF, will fix those problems, but even SAF is still expensive and scarce. Another issue is airline economics. United and American Airlines have placed non-binding orders for Overture jets, but those are just preliminary commitments, not firm purchases. If Boom can't meet performance, cost, or environmental standards, those deals could vanish overnight. Still, there's a sense of hope in the air. Boom continues to expand its production site in North Carolina, hires engineers, and releases polished visuals of its factory and aircraft design. The company's PR message remains steady: we're on track. The future is supersonic. But behind the optimism lies a harsh truth. Without a working engine, a successful prototype, and massive funding, that future remains uncertain. And while Boom fights for survival, new rivals are emerging on the horizon.
While Boom Supersonic works to bring back the age of high-speed travel, it's far from the only one chasing that dream. Around the world, governments and corporations are racing to develop the next generation of supersonic and even hypersonic aircraft, each with its own strategy, goals, and technological edge. Leading the pack is NASA's X-59 QuesST project, built in partnership with Lockheed Martin. Unlike Boom, which targets commercial passengers, NASA's focus is on solving one of the biggest obstacles to supersonic flight: the sonic boom. The X-59 is designed to dramatically reduce the thunderous crack that happens when a plane breaks the sound barrier, turning it into what engineers call a sonic thump. If NASA succeeds, it could pave the way for regulators to finally allow supersonic flight over land, not just over oceans. And that single breakthrough could completely reshape the economics of fast air travel. Meanwhile, China and Japan are developing their own high-speed aircraft projects, both military and civilian. China's aerospace sector, with companies like Comac and Avic, is investing billions into hypersonic propulsion research, and there are even reports of experimental passenger concepts for Mach 2+ travel by the 2030s. For Beijing, it's not just about speed. It's about technological self-reliance and national prestige. Even in Europe, Companies like Destinus in Switzerland are exploring hydrogen-powered supersonic jets, betting that clean fuel could solve both the environmental and political challenges of this industry. The global race for the next Concorde isn't about nostalgia anymore. It's about who will own the skies of the future. For airlines, the potential is tempting. Business travelers and VIP passengers are willing to pay a premium for time, the one thing technology still can't replace. A New York to Tokyo flight in 6 hours could rewrite global business schedules. But so could a catastrophic failure if any of these companies rush too soon. As the competition heats up, Boom's biggest challenge may not be engineering. It's staying relevant in a race that's quickly evolving beyond it. Every year that passes without a flight, new players, technologies, and governments enter the game. The question is no longer whether supersonic travel will return, it's who will bring it back first. And Boom might not be the only contender left standing when the dust settles.
So where does Boom Supersonic really stand today? The company claims its first full-scale Overture jet will roll out by 2026, with commercial flights expected around 2029. But those dates depend on everything going perfectly: engine tests, certifications, funding, and most importantly, trust from the industry. If Boom succeeds, it could mark the return of the supersonic age, proving that speed and sustainability can coexist. The Overture could become the modern Concorde, faster, cleaner, and quieter, opening a new chapter in aviation history. But if it fails, it will serve as a reminder that even the boldest dreams can crash against the hard limits of physics, money, and regulation. Still, one thing is certain: Boom has reignited the world's imagination. For the first time in decades, people are once again talking about flying faster than sound. Whether that future belongs to Boom, NASA, or another rival, the pursuit itself is what keeps innovation alive. If you found this breakdown useful and learned something new about the future of flight, make sure to leave a like. It really helps the channel grow. And don't forget to subscribe for more deep dives into aviation's most ambitious projects.